Clay, pebbles and debris are carried down by the river Brahmaputra and Padma. Both the river carries huge amount of silt with them, so they get deposited in Bangladesh. So most of the part of Bangladesh is covered by clay soil. In the north of Bangladesh, there is your Meghalayan plateau that consists, there is a remarkable three peaks, Garo, Khassia and Jaintia. Try to follow. This moisture-laden air mass passes through Bangladesh, causing no rainfall in Bangladesh. But whenever this moisture-laden air mass gets prevented by the southern slope of Meghalaya, the Meghalayan plateau, then it is your Cherrapunji Mawsynram receives the largest amount of rainfall in the world, which is near about 1350 centimeter. 1350 centimeter annual rainfall is received by the southern part of Meghalayan plateau. It is to be mentioned that to the northern part of Meghalaya, this is your Shillong, it receives scanty rainfall than that of the southern part. Why? Because it is situated in the rain shadow area. Now, what do you mean by rain shadow area? This type of rainfall is known as orographic rainfall. I am giving an example like this. Suppose this is your moisture-laden air mass. It is windward slope and this is your leeward slope. Windward slope and leeward slope. Suppose this is your moisture-laden air mass. When it is forced to ascend along the slope, then it loses its temperature according to the normal lapse rate. Then water vapor present in the atmosphere gets condensed and causes rainfall in the windward slope. This type of rainfall is known as orographic rainfall. After causing the rainfall, when it passes over the next slope, that is leeward slope, it has no remarkable amount of moisture with it, so it doesn't cause any rainfall or maximum rainfall. So this area receives scanty rainfall. This slope, leeward slope, is known as rain shadow area that receives the scanty rainfall in comparison to the windward slope. This type of rainfall is known as orographic rainfall. It is also to be mentioned, the Indian annual rainfall maximum takes place in this type, that means orographic rainfall. Now follow me. 1350 centimeter rainfall is received by the southern part of Meghalayan plateau, where is your Cherrapunji and Mawsynram. To the north of the Cherrapunji and Mawsynram, there is your Shillong, the capital of this state, receives scanty rainfall as it is located in the leeward slope. On the other hand, this is your Himalayan mountain range. This is your low pressure trough in the Tibetan plateau. When the moisture-laden air mass tries to cross the Himalayan mountain range, then it causes maximum rainfall towards the southern slope of the Himalayan mountain range. When it tries to ascend along the southern slope of the Himalayan mountain range, it causes rainfall, and not only that, it also causes the unequal distribution of rainfall. Just like this, in the eastern part of the Himalayan mountain range, it receives 400 centimeter rainfall in Alipurduar, 300 centimeter rainfall in Darjeeling, as the wind cannot cross the Himalayan mountain range under the attraction of another low pressure cloud on the desert area of Rajasthan, Thar desert, the wind blows towards west. Wherever this wind blows towards west, it causes rainfall and gradually the amount of rainfall decreases. In this way, in West Bengal, 200 centimeter rainfall, 150 centimeter rainfall in UP and Bihar. When it reaches further towards west, there is 100 centimeter rainfall, and in Rajasthan, less than 50 centimeter rainfall. In this way, temperature amount of rainfall is decreasing gradually towards west, because the wind which is prevailing, which is blowing towards north, there is no scope for the wind to retain more and more moisture, because it is blowing over the surface of landmass. So it causes rainfall, and at the rate of unequal amount of rainfall is distributed all over the northern states. Try to follow. In the last class, I have mentioned just like this a curve. This is called axis of monsoon. Advancement of monsoon is denoted by this isoheight line. These lines are known as isoheight line. What do you mean by isoheight line? Isoheight line or isoheight is nothing but the line joining the stations receiving the same amount of rainfall is known as isoheight. This isoheight line, gradually it advances towards the west up to July, August, September. In this way, it advances towards the west. On the other hand, this Arabian Sea branch receives moisture, but which is prevented by the Western Ghat. Western Ghat, this is your Western Ghat, and southern part is Nilgiri. There are three remarkable gaps: Thalghat, Bhorghat, and Palghat. Along the western slope of the Western Ghat receives maximum rainfall. Why? Because this Arabian Sea branch gets prevented by the western slope of the Western Ghat. So the western coast along with the western part of the Western Ghat receives near about 300 centimeter annual rainfall. On the other hand, this is your Aravalli mountain. I will explain the reason of formation of Thar desert just now. This is your Aravalli mountain. The wind blows towards north in this direction. Try to follow. The wind direction is just parallel to the location of Aravalli mountain. So Aravalli mountain is not able to prevent this moisture laden air mass over the Thar desert. So this air mass, though it retains maximum moisture, but it is unable to cause any rainfall over the Thar desert. Whereas this is your Shivalik. Suppose this is your Shivalik mountain, the southernmost range of the Himalaya. Shivalik mountain range prevents this moisture laden air mass on the other hand and causes rainfall in this area near about 50 to 100 centimeter. Okay? Along the coastal area, amount of rainfall also decreases in the eastern part of peninsular India. This is your peninsular India. Why? Because this eastern part of the Western Ghat is in the rain shadow area. So the central part of Indian territory receives only 100 centimeter rainfall. This is the distribution of rainfall, and this rainfall takes place for the 4 months: June, July, August and September. This is your apparent movement: June, July, August and September. As September, up to September month, Indian territory, total territory, receives the annual maximum and 90% rainfall, and 90% annual rainfall. Okay. During the season, the southwest monsoon changes its direction. Why? Due to apparent movement. As look at this figure: September here, October, November and December. October, November. In the month of October and November, the southwest monsoon changes its direction. In the month of October, there is the existence of two types of wind. Gradually, this southwest monsoon ceases, and northeast monsoon begins to blow. So, due to the existence of two types of wind at its opposites, at their opposite direction, certain cyclonic weather exists along the coastal area. Due to presence of this cyclone, the eastern coast of Andhra Pradesh and Odisha receives one kind of stormy weather which is known as Ashini Jhor. It is due to presence of these two type of wind at their opposite direction, and they are quite different in nature and temperature. This is Ashini Jhor. The northeast monsoon becomes stronger and stronger than that of the southwest monsoon. On the other hand, southwest monsoon becomes weaker and weaker because of the apparent movement of the sun. The sun is gradually moving towards south, so this high pressure trap over the Indian Ocean gradually becomes low. On the other hand, as the sun is apparently moving towards south, then this low pressure turns into high pressure over the Tibetan Plateau once again. Gradually, gradually the wind blows towards south from the north direction. This period is known as retreating monsoon, that exists for the 2 months, October and November, 2 months. Next, the fourth season, winter, December to February, that exists for 3 months, 3 to 5, 5, 4, 9 plus 3, 12 months, 1 year cover. Now, I will explain the fourth and last season of Indian monsoon, which is known as winter, that exists over the Indian territory from December to February. It exists for 3 months. Try to follow. There is your high pressure over the Tibetan Plateau as well as over the Himalayan mountain range. You know, so many mountain peaks are there over the Himadri mountain range that remains ice-capped all throughout the year. So this ice-capped mountain peaks receives cold and low, very, very low temperature that blows towards south under the attraction of low pressure that exists over the Indian Ocean. The wind changes its direction in this way. Just opposite to the southwest monsoon. This is called north-east monsoon. This is northeast monsoon. The totally a southwest monsoon loses its existence. In the winter season, there is no trace of southwest monsoon, only the northeast monsoon exists, and as it is blowing over the land surface, there is no scope of retaining moisture for this prevailing wind. So it is dry in nature, as it retains no moisture. It is heavier in nature because it is dry and cold. It is cold in nature because it is blowing from north to south. So the characteristics of this wind just opposite to the southwest monsoon. Northeast monsoon characteristically dry, cold and heavy. On the other hand, southwest monsoon that we explained just before, warm, moist and light. This wind blows towards south gradually over the Indian territorial peninsula. India loses its temperature with the blowing of northeast monsoon. Try to understand. As it is blowing over the land surface, land surface receives the high temperature within a short period of time, and according to its high density, it loses its temperature also within a short period of time. So the losing and retaining of temperature depends on the density of physiography, density of rocks. Different types of rocks are there. So this granitic and gneiss topography, this total peninsula consists of granite and gneiss topography, gneiss rocks. That is also one kind of igneous rocks. It loses its temperature within a short period of time. So this becomes very colder one along the Himalayan mountain range, and this is your Dras in Ladakh. Dras in Ladakh. This is the coldest point of India in Dras in Ladakh. And on the other hand, along the Himalayan mountain range, the temperature less than 0 degrees centigrade. With the increasing elevation, temperature decreases at a certain rate of 6.4 degrees C per 1000 meter of height. So, along the tops of the Himalayan mountain range, most of the parts remains ice-capped in this season. Not only that, cold, dry, heavier wind blows towards south. So, this northern plain loses its temperature within a short period of time. Then, in the Himalayan mountain, other than the Himalayan mountain range, this in West Bengal, temperature remains in the winter season 15 to 18 degree. On the other hand, there is a great variation of temperature during day and night. Well, this is your Rajasthan Thar Desert. In the Thar Desert, a remarkable range of temperature, that means variation of temperature, is found in the Thar Desert. Why? The desert consists of silica or sand particles, which is the fragments of rocks that gets heated within a short period of time, that loses its temperature within a short period of time. Okay? In the winter season, temperature 12 degrees C in the central part, plateau region in the Chotanagpur plateau 10 degrees centigrade. On the other hand, 7 to 10 degrees centigrade in the Rajasthan. And in the southern part, due to the close proximity of the ocean, the temperature remains 18 degrees centigrade along the coastal area. or along the eastern coast and western coast due to close proximity of the ocean. Okay? Now, the two remarkable phenomena, climatic phenomena, is experienced during this winter season, which is westerlies disturbance. Westerlies disturbance. What is westerlies disturbance? Suppose this is your Pakistan. This is your Shivalik mountain range. From the western part, the Mediterranean type of climatic zone is there. The Mediterranean climatic zone is to the west of India. Pakistan, Afghanistan, Iran, Saudi Arabia and Mediterranean Sea. In between this, there is your Syria and Turkey, Israel, Lebanon, Jordan, etc. From the Mediterranean Sea, this moisture-laden air mass comes to the northwestern part of India, where is your Punjab, Haryana, Punjab and Haryana and UP. Due to presence of this moisture-laden air mass from the Mediterranean climatic zone, this moisture-laden air mass causes certain amount of rainfall, which is not much more, but ideal for the cultivation of wheat in winter. You know, most of the part of Indian agriculture is used for the cultivation of wheat during winter season, when Indian territory actually doesn't receive any rainfall due to presence of this northeast monsoon wind. So only this area which I want to mention, the UP, Haryana and Punjab receives certain amount of rainfall due to presence of this wind coming from the Mediterranean type of climatic zone. On the other hand, in the central part of Asia, eastern part of Central Asia, this is it is called the westerlies disturbance. Westerlies disturbance, due to presence of this westerlies disturbance, the northwestern part of India receives certain amount of rainfall, which is ideal for the cultivation of wheat in winter. On the other hand, in the month of November, December, Coromandel coast, this is your Krishna river mouth, this is your Godavari river mouth and Krishna. From the Krishna river mouth to the Cape Cameroon, this coastal area is known as Coromandel coast. This Coromandel coast receives rainfall twice in a year. Number one, during the southwest monsoon period, this area receives rainfall, and second time, when the northeast monsoon blows, this northeast monsoon receives moisture from Bay of Bengal gradually. After leaving the landmass, it blows over the ocean, and with the increasing temperature, it retains moisture and causes rainfall. You see, in the coast of Coromandel, this area receives rainfall twice in a year. Okay, it is one kind of cyclonic rainfall also. Cyclonic rainfall due to close proximity or due to interaction of the two type of wind, which is dry and another moisture laden. And these two type of, due to presence of these two type of wind and due to interaction of these two type of wind, a cyclonic rainfall happens to be there. So this type of rainfall causes the twice rainfall in the second time rainfall along the coast of Coromandel. Okay, these two climatic phenomena characterized the Indian winter season. Okay, I have already mentioned the 4 seasons in this class. Number 1, summer. It was explained in the last class. Now I have already explained incoming monsoon period from June to September, retreating monsoon October and November, and winter season December to February. Okay, this is your climate of India. You may ask any question if you have on this topic. Whenever you require any answer of any question from your book, from anywhere, you may ask me through WhatsApp or over phone. Okay, thank you all.